Hey guys, welcome back to another video for Math 7. I'm not going to be making a lot of announcements in the videos because I'm recording beforehand, and so I know that now I have to start giving tests, and there will be like a trial to see how it goes. The only thing is that check Google Classroom more often, especially this coming week, because this first test is going to be very important to set up how the test is going to be. But it's going to be like every test that we've had I'm going to try to keep it as normal as possible. And so I can't give you the whole day to do the test. I can give you maximum 2 hours, okay? So you have to be attentive to Google Classroom. We'll see what happens there. The announcements are going to be in Google Classroom. That's all I can tell you, because I'm not even sure when this video is coming, since everything was shifted around. Since first it was going to be just 10 days of teaching straight. Then they said, no, we're going to extend it. And then Dr. Schweitzer said, no, but we're going to have spring break and everything like regular school. So yeah, everything kind of like switched. And because I had done the videos way too early, things changed. So let's just get into the lesson today. Today is going to be lesson 106, which is solving literal equations, transforming formulas, and transforming formulas, and more en route. It's supposed to be 4 examples, so hopefully it's not too hard. But again, I think 5 examples. But I think the first part, transforming formulas and literal formulas, changing them, like manipulating them, is going to be a little bit tough for some of you. So I do have to show you in the board how to do it. And hopefully you follow along with what I'm doing. Okay? This is one of those lessons that I know that I wish I could show you in the board. And you could ask me questions. And the reason I'm not doing Zoom is because I need you to look at the board. I don't really care if you can see me. I'm not that important. The board is super important, the way that I do math. And because with paper and pencil is not the same. I've used Zoom before, and it's not something that I think it's conducted for this class specifically, in which I have to show you a lot of things on the board. And so this is the best we have so far. And so, yeah, let's get into it. Okay, example 1, it says solve for x. So we have something here that says x plus a equals b. So it's not super hard. And one of the things that happens is that a lot of kids get confused just because we started using letters, all letters, and no numbers or constants. And so it's all variable, no constants. And they're like, wait, what happened? Why is it so hard? But I promise you, it's not that hard. It's the same concept. It's the same idea. Because here, to be able to get x by itself, since we're solving for x, what we have to do is see what is happening here. So is b affecting x? No, it's not. It's on the other side of the equal sign. So b doesn't even have to be moved. Is a affecting x? Yes, it is. So we have to move the a to the other side. How are we going to move it? Well, what is a doing to x? A is adding to x. So to be able to move it to the other side, we have to subtract by a. So we're going to subtract a on both sides. And so we're going to have x equals b minus a. And that would be the answer to the first example. So in the first example, even though we didn't use numbers, we use principles that we've been using before just for solving equations in itself. And so it's not that it's a hard concept, it's just the letters trip some people up. And I'm telling you, the letters don't make it that hard if you understand what the letters are doing to each other, because they're just like the numbers, okay? And it's okay to have b minus a as an answer because we don't know what b or a or x are. This is what they're asking for. All right, so let's move on to example 2. All right, for example 2, it says solve for x again, but the problem changes a little bit, and it is axb. So ax equals b. Okay, so that's the example, ax equals b. So now what we have to do is probably write the b the right way. Once you actually get down to actually writing what it's supposed to be, Some people might struggle like I just did right now, but it happens to the best of us. So then we have to know, is B affecting A or X? No, B is by itself. B is all alone, forever alone. Just like Mr. Silva. And so then what we have to do is find A times X, right? A and X, what are they doing? They're multiplying each other, right? So what we have to do is divide by A. And when we divide by A, we have to do it on both sides because it's an equation. We have to balance the equation. A divided by A is the same thing as 2 divided by 2. It's still 1. 1 times X is going to be X. So it's going to be X equals B over A. And that would be the answer to the second example. Again, it's not very difficult, but what happens is that you guys get really confused with just using letters. You guys are like, well, but where's the numbers? Unfortunately for you guys, math is going to start looking a lot more like this. Just a bunch of letters, very little numbers in between. And so you have to get used to it. It's one of the ways in which we are introducing you to algebra. In fact, you have been doing algebra for a little bit, but you guys don't know it yet. So yes, this is how you do example 2. Let's move on to the other sections in the lesson. Okay, in example 3, we are going to use the same concept that we used before. But now what we're saying is, okay, we have a rectangle, right? And we know that the area of the rectangle is length times width. But now what we're going to do is, what happens if they give us the area and they give us the length, but they don't give us the width? And they want us to find the width. What they want you to do is to solve for W, solve for the width, before putting the numbers in there. That's what one of the reasons that we want you to be able to manipulate or move around the variables is, so that you can move the variables and it is easier for you to understand what you're doing. And so what we need to understand is that the area is not really affecting the width, is the length, because length times width equals the area. So what we have to do again is, because the length is multiplying times the width, we have to do the opposite of what the length is doing, which is division, because the opposite of multiplication is division. So we're going to put length in here, and we have to do it on both sides because it is, that looks like something else. There you go. Much better. Yeah, that looks like a Greek letter. Something like that. All right, so the length then is going to cancel itself because length over length equals 1. 1 times W equals W. And so the area divided by the length will give you the width. And that is what they're looking for. And this is one of the reasons that you need to learn how to do this, to be able to find whatever we're asking you to find in different equations. And so this is it for the first part of the lesson. Now let's move on to the last part of the lesson with square roots. To get into the next part of the lesson, we have to understand something that happens to squares. Before we talk about square roots, we have to talk about squares. So 5 squared. What is 5 squared? And what is the difference between 5 squared and negative 5 squared? Well, 5 squared is going to be 5 times 5, right? That's the very basic idea behind it, 5 times 5, which is going to be 25, right? I mean, that's it. And in here we have negative 5 times negative 5. Well, negative and negative is positive, and 5 times 5 is still going to be 25. So 5 times 5 is 25. Negative 5 times negative 5 is 25. So understand something. In here, when we do the square of 5 or the square of negative 5, they're going to give us the same answer. And so there is something that happens when we say, okay, so give us the square root of 25. Well, the square root of 25 could be 5, as we saw here. But it could also be negative 5, because we just saw that negative 5 times negative 5 is 25. And so what we need to understand is that there's this notation called plus or minus 5. Okay? It's okay if you use it in tests, but your book wants you to put square root of 25 is going to be either 5 or negative 5, which is true. It's 5 or negative 5. That's exactly right. And so this is what you need to understand before we move on to the next examples, because you have to understand that negative 5 squared or 5 squared equals 25. And so the square root of 25 is going to be positive 5 or negative 5, okay? And so, example 4 says, what are the 2 square roots of 5? And so that means that what we're doing is we're square rooting 5. Well, first of all, 5, it's a prime number. We don't know what square root of 5 is, but that's not the question. That's not what they want you to know. What they want you to know is, do you understand the concept that we just talked about, in which square root of 5 times square root of 5 is going to be 5, right? Because square root of 5 squared is going to be 5, but negative square root of 5 squared is also going to be 5. And so in here they're saying, what are the 2 square roots of 5? Well, one of them is going to be positive square root of 5, and the other one is going to be and square root of 5. By the way, I know that I put or in the other one, but it has to be and. Square root of positive square root of 5 and negative square root of 5. Those are the answers to this question. We're not really worried about what number it is. We're worried more about the concept in which you understand that it has to be the same thing, positive and negative, because positive squared is going to be positive and negative squared is going to be positive. Okay, because positive times positive is positive, and negative times negative, it's positive. Just remember Mr. Silva's magical table, right? And so let's move on to example 5 to finish this lesson. So this example actually introduces to a new notation called the cubed root. All right, the cubed root of 1,000 and the cubed root of negative 27. The cubed root is the same thing as the square, well, it's not the same thing, but it comes from the idea that this is a square root of 100, right? So the square root of 100 is 10. Why is the square root of 100 10? Because 10 times itself, times 10, equals 100. So they're saying, what number multiplied by itself 2 times, 1 and 2, 2 times, will give you 100. And so that's what they're asking here, except instead of what number multiplied by itself 2 times is what number multiplied by itself 3 times will give you not 100, but 1,000. Well, this is actually pretty easy because we understand something. 10 times 10 is 100. And what is 100 times 10? Well, 100 times 10 is 1,000. All right. Now, I also made you memorize a bunch of cubes. So hopefully you guys remember it. You only had to memorize it until like 5, I think. So it was 1 cubed equals 1. 2 cubed is 8. 3 cubed is 27. 4 cubed is 64. And 5 cubed is 125. Those are the ones that you have to memorize. It just makes it a lot easier, just like the squares. Like, for example, if we ask you, what is square root of 169? If you don't know that that is 13 squared, then you have to use a calculator. Or what is square root of 256? If you don't know that that's 16, then you have to actually use a calculator. And as you know, you cannot use a calculator. So you have to just bear with us. And so what they're asking is, what number multiplied by itself 3 times will give you 1,000? And that number obviously is 10, because I showed you it's 1, 2, and 3. If I multiply 10 times itself 3 times, I'm going to get 1,000. And in here, I kind of already gave you the answer, but it's weird because it's negative. So what would it be? Well, this comes to one of the previous lessons. I don't remember what number because I've been teaching so many and recording so many classes. But I remember we talked about even and odd exponents. And so if it's even exponents, it will always be positive. But if it's odd exponents, it will be negative if the base is a negative number. So we know that the base has to be a negative number. What is the base? The base is the big number that we have here. And then the exponent, or is what we raise to the power of 3. 1 to the power of 3, 2 to the power of 3, 3 to the power of 3, 4 to the power of 3, 5 to the power of 3, or cubes, right? So much easier to say cubes. That's why we like it. And so cubed root of negative 27 is going to be a negative already because it's odd number. And so then we know, because of what we know here, that it would be negative 3. And so that's pretty much it. It's not that it's very hard, but you have to memorize at least these ones right here. And for 10, you don't really have to memorize the one for 10, because what is the quartic root, or the fourth root of 10,000? Well, the quartic root of 10,000 is 10. How did I do that? Well, because 10 multiplied by itself 4 times is going to give you 10,000. Or you're going to 10 to the fourth is going to be a 1 followed by 4 zeros. And that's a trick in math. So the fifth root of 100,000, not 0, not 1, but 0, it's going to be 10, because it's the same thing as 10 to the fifth power, and so it keeps on going. So that one you don't really have to memorize, as long as you understand that because there's 3 zeros, it's the same thing as 10 cubed, which is 1,000. 10 cubed means 1 followed by 3 zeros, and so forth. And that you also have to know a little bit for scientific notation, which I know we've been doing. So yeah, that's it for lesson 106. Hope you guys enjoyed it, obviously, and that you learned and that you went on this wild ride with me. But yeah, I'll see you tomorrow. Have a good one.